Today we're going to look at the formation of tores. Now, tores are a feature that is produced as a result of massive igneous intrusions. And when we think of massive igneous intrusions, the best example in South Africa is the Paarl Rock. Now, the Paarl Rock is a batholith. Now, batholith is where we get a massive igneous intrusion deep down in the Earth's crust. And so it doesn't form on the surface as volcanic igneous formation. It's a plutonic igneous formation that forms deep down in the Earth's crust. And so when we look at the Paarl Rock or the batholith, we see that it's got a dome-like feature. And when we draw the contour lines over the orthophoto map, we begin to see how it's got a very steep convex slopes. So it's definitely a dome feature. When we look at the digital elevation model, we can clearly see the domes. So we see it in 3D, so it's a rounded feature. But at times, a massive igneous intrusion like this can actually be broken down so that by the time it's exposed to the surface, it looks different to what we see in the case of Paarl Rock. So that's the formation of a tor. Now let's look at the formation of a tor. So we have the overlying layers of rock, which is called the country rock. And so what happens is this, that magma then comes into the Earth's crust, solidifies deep down, it cools, and then what happens, it shrinks. And so then we get shrinkage joints. And these shrinkage joints are the points along which weathering will then occur over time. But in the meantime, what happens is the overlying rock is removed by erosion. And so what happens is it causes the batholith to expand because now there's an unbundling. The joints become deeper and maybe a bit wider, and we get more joints. And now this is where the weathering is going to occur to create weathering along those joints. And as the overlying rock is removed, water can now make ingress and chemical weathering can occur along those joints. And so what now happens is this, that eventually we're going to get rounded stones that form. And so when this batholith is then exposed to the surface, we now no longer see it as a solid batholith, but rather the material that is weathered is removed, and we end up having core stones that balance on top of each other. And so there we have the tor forming. So can you see it's a process of unbundling that occurs and also chemical weathering. But now when we look at an example of the Paarl Rock, we see that this did not happen in the case of the Paarl Rock. And the reason why that is so is because can you see the joints are very far apart. So chemical weathering could not have broken down the rock. So let us look at now the process and formation of the tor as a timeline. So first of all, what we get is magma coming into the Earth's crust, cooling and then shrinking. And then what happens, the overlying country rock being removed, unbundling, and then what does it do to the batholith? Chemical weathering occurs, we get the core stones forming, and then eventually when it's exposed, those core stones then balance on top of each other to create the feature as a tor, and so there we get the full formation of the tor.